When data items are stored in a computer system, they can be stored for varying periods of time, temporarily or permanently. Temporary storage is usually called computer memory or random access memory, RAM. When you write a Java program that stores a value in a variable, you are using temporary storage. The value you store is lost when the program ends or the computer loses power. This type of storage is volatile. Permanent storage, on the other hand, is not lost when a computer loses power. It's non-volatile. When you write a Java program that saves it to a disk, you are using permanent storage. Files exist on permanent storage devices such as a hard disk, zip disk USB drives, magnetic tape, or compact disks. Computer files are the electronic equivalent of paper files often stored in the file cabinet in office. You can categorize files by the way they store data. Text files contain data that can be read in a text editor because the data has been encoded using a scheme like ASCII or Unicode. Binary files contain data files that haven't been encoded as text. Their contents are in the binary format, which means you cannot understand them by viewing them in a text editor. Example includes images, music, and compiled programming files like a .class extension that you have created using this book. When you work with the stored files in an application, you typically perform all or some of the following tasks. Determine whether and where a file exists. Opening a file, reading data from a file, writing information to a file, closing a file. As name suggests, path is the particular location of an entity such as a file or directory in a file system, so that one can search and access it at a particular location. Technically, the terms of Java, path is an interface which is introduced in Java NIO file package and is the representation of location in particular file system. As path interface is in Java NIO package, so it gets its qualified name as a java.nio.file.path. In general, path of an entity could be two types. One is an absolute path and the other is relative path. As name of both paths suggests that the absolute path is the location address from the root to the entity where it locates, while relative path is the location address which is relative to some other path. Path uses a delimiter in its definition as a backslash for Windows and a slash for Unix operating system. Java NIO package provides one more utility API named as a files, which is basically used for manipulating files and directories using its static methods, which mostly work on path objects. This class consists exclusively of static methods that operate on files, directories, or other types of files. In most cases, the methods defined here will delegate to the associated file system provider to perform the file operations. You can include import java.nio.file.star in a Java program to use both the file and the path classes. The NIO in Java NIO stands for New Input Output because its classes are new in that they were not developed until Java 7. To create a path, you first determine the default file system on the host computer by using a statement such as the following: file system fs equal file systems dot get default. So this statement creates a file system object using the getDefault method in the file systems class. The statement uses two different classes. The file system class without an ending s is used to instantiate the object. File systems with an ending s is a class that contains factory method, which assists in object creation. After you create a file system object, you can define a path using the getPath method. So path pass equal fs dot get pass. Then inside the parentheses, you have a double quote. You specify C drive, then backslash, that's for Windows, then Java, the pass to the file. An absolute pass is a complete pass. A relative pass is a pass depends on other pass information. This table summarizes several useful pass methods. As you have learned with the other classes, the toString method is overridden from the object class. It returns a string representation of the pass, and the double slash are omitted. Basically, it's a list of pass elements separated by copies of the default separator for the operating system. So for the Windows, it's backslash. For the Unix, it's a slash. The getFileName method returns the last element in a list of pass names. Frequently, this is a file name, but might be a folder name too. The getNameCount method returns a number of name elements in the pass. The getName, then you pass the integer as a parameter, it returns the name in the position of the pass specified by the integer parameter. This program shows a demonstration program that creates a pass. So pass file pass equal pass.get. So the file is on the C drive, Java folder, chapter 13 folder. Then the name is dummy.txt. Integer count equal file pass.getNameCount. GetNameCount will return the number of name elements in the pass. It should have 3 elements, Java, chapter 13, dummy.txt. The next one, system.out.println, pass is file pass.toString. So the toString returns a string representation of the pass, and the double backslash is eliminated. From the output, you can see the message is pass is a C colon and backslash Java backslash chapter 13 backslash double dummy.txt. So the separator backslash is eliminated. The next line, system.out.println, file name is, then concatenate file pass.getFileName. GetFileName returns the file or directory denoted by this pass. This is the last item in the sequence of name elements. So the last item is a dummy.txt. So the message is file name is dummy.txt. Then we have a for loop to print out each element of the name elements. So element 0 is Java, element 1 is chapter 13, element 2 is dummy.txt. So the getName method receives the counter argument and it returns the name in the position of the pass specified by the counter. The toAbsolutePass method converts a relative pass to an absolute pass. For example, in this program, the user enters a file name and the toAbsolutePass will return the full pass of the file. From the output, we can see if I enter dummy.txt, the message will show the full pass of this file. So we first use a pass.get. File name will be the argument to create a pass object, which is an input pass. Then we call input pass dot to absolute pass to get the absolute pass of this file. To verify a file exists and that program can access it as needed, you can use the check access method. We need the import statement. Import static java.nio.file.accessMode.**. This allows you to access constant that can be used as argument to the method. In this program, we declare a pass called a file pass, and we use file pass.getFileSystems.provider.checkAccess method. So we can use any of the following constant arguments for this check access method. No arguments. If we don't apply arguments, we will check if the file exists. If we supply read, it checks if the file exists and that program has permission to read the file. Write checks if the file exists and the program has permission to write to the file. Execute checks if the file exists and the program has permission to execute the file. So in this try block, we have a file path.getFileSystem.provider.checkAccess, and we pass the file object, which is a file path. Then we pass the read and the execute arguments. So from the output, you will see the message, file can be read and executed. If the file cannot be read and execute, the try block will throw expression, so the catch block will be executed. So the message file cannot be used for this application will be displayed. The file class delete method accepts a file parameter and deletes the last element, which is the file name or directory, in a path or throws an exception if the deletion fails. For example, if you try to delete a file that doesn't exist, a no such file exception is thrown. A directory cannot be deleted unless it is empty. If you attempt to delete a directory that contains files, a directory not empty exception is thrown. If you try to delete a file but you don't have permissions, a security exception is thrown. So other input-output errors cause an I/O exception. This program displays an appropriate message in each of the preceding scenarios after attempting to delete a file. You can use the readAttributes method of the files class to retrieve useful information about a file. The method takes two arguments, a path object and the basic file attributes.class, and it returns an instance of the basic file attributes class. So you might create an instance with a statement such as basic file attributes attri equal files.readAttributes file path basic file attributes.class. After you have created basic file attributes object, you can use several methods for retrieving information about a file. For example, the size method returns the size of a file in bytes. Methods such as a creation time and the last modified time return important file times. When you need to retain data for any significant amount of time, you must save the data on a permanent secondary storage device such as a disk. A character can be any letter, number, or other special symbol. When business use data, they group characters into fields. A field is a group of characters that has some meanings. Fields are grouped together to form records. A record is a collection of fields that contain data about an entity. A data file can be used as a sequential access file, when each record is accessed one after another in the order in which it was stored. A file of a comma-separated value, CSV, is one in which each value in a record is separated from the next by a comma. CSV is a widely used format for files used in all sorts of applications, including database and spreadsheets. Before an application can use a data file, it must open the file. So Java application opens a file by creating an object and associating a string of bytes with it. Similarly, when you finish using the file, the program should close the file, that is, make it no longer available to your application. When you input an input operation in an application, you can picture bytes flowing into a program from an input device through a string, which is functioned as a pipeline or channel. When you perform output, some bytes flow out of your application through another string to an output device. A string is an object, and like all other objects, strings have data and a method. The methods allow you to perform actions such as opening, closing, reading, and writing. Buffer is a memory location where bytes are held after they are logically output, but before they are sent to the output device. Using a buffer to accumulate input or output before issuing the actual I/O command improves program performance. When you use an output buffer, you sometimes flush it before closing it. Flush clears any bytes that have been sent to a buffer for output but haven't yet been output to a hardware device. This figure shows a partial hierarchy relationship of some of the classes Java use for input and output operations. It shows that input string, output string, and the reader are subclasses of the object class. All three of these classes are abstract, so it contains methods that must be overridden in their child classes. The figure also shows the major I/O child classes that we will learn in this chapter. This table summarizes the capabilities of those classes. For example, as the name implies, the output string class can be used to produce output. For the output string method, we have a close, flush, write. Java's system class contains print string object named system.out. So by default, it will go to the command line on the monitor. We also have a system.err is usually reserved for error messages. You can direct either system.err or system.out to a new location, such as a disk file or printer. In this program, string s equals ABCDF, so it declares a string of a letter grade. Then the getBytes method converts this string to an array of bytes. Output string, output equal no. An output string object is declared, and in the try block, we assign system.out to this output string object. So output equals system.out. Then we call the write method and we pass the data, which is the byte array, as an argument, and we call flush method to flush the output string. And we call the close method to close the output string. From the output window, we can see the byte array ABCDF is displayed. In this program, we output the contents on screen. In previous slide, we assigned system.out to the output string, so the result will be displayed on the screen. If you want to put data in a file, you can construct a buffered output string object and assign to the output string. This example shows an application that writes a string of bytes to a file. The only difference from the preceding screen-out class are, first of all, we need an additional import statement. So we say import java.nio.file.*; import static java.nio.file.stand_open_option. We will talk about the standard open option next slide. For this one, we use the option create to create a new file. Second difference is the path is declared for a grades.txt file. We have path file equal path.get, then C drive, Java folder, chapter 13 folder, then the new file name is grades.txt. The third difference is instead of assigning system.out to the output string reference, a buffered output string object is assigned. So we have an output equal new buffered output string, files.new output string, then file, we pass file and the create option. From the output, we can see when the file out program executes, no output appears on the monitor, but the file is created at the location specified in the path statement. And the grades.txt contains the string bytes. ABCDF. In previous program, we pass files.newOutputStream, then file, then create option. There are other options like a write option, open the file for writing, append, truncate the existing file to 0 bytes so the file contents are replaced, and a create_new, that's a create a new file only if it doesn't exist. We already passed the create option, which opened the file if it exists or creates a new file if it didn't. Then we also have a delete_on_close. It deletes the file when the stream is closed, used most often for temporary files that exist only for the duration of the program. So we write file by using output stream, and we can use an input stream to read file. So if you want, you can create an input stream, assign system.in to it. So we read from the screen. However, we usually use it to read from a file, right? If we want to read on the screen, we can just use the scanner class for keyboard input. So input stream can open a file for reading, and we can use the file class new input stream. So for writing to a file, you use a new output stream. For reading from a file, you use a new input stream. This program shows a read file class that reads from a grade.txt file created early. The path is declared, and the input stream is declared using the path, and the string is assigned to the input stream reference. The read file class declares a buffered reader object. A buffered reader reads a line of text from a character input stream, buffering characters so that reading is more efficient. When the read file program executes, the read line methods get the single line of text from the grade.txt file, and then the line ABCDF is displayed. If you want to read and display multiple lines from the file, we should use a loop, like a while loop, to read each line until the end of the file. The flag for the while loop can be while the reader.readLine returns not equal to no, so the loop continues, otherwise it stops. When you use buffered reader class, you must import java.io package into a program. This table shows some useful buffered reader methods: close, read, and there are several overloading read. There are several parameters. Read characters into a portion of array from position off for the length of characters. Then read line, we see that in previous example. Skip the specified number of characters. More frequently, you want to save more than a single string to a file. For example, you might have a data file of a personnel record that includes ID number, name, and pay rate for each employee in your organization. So this figure shows a program that reads employee ID number, names, and the pay rates from the keyboard and sends them to comma-separated file. The program creates a buffered writer named writer. The buffered writer class is the counterpart to the buffer reader. It writes text to an output stream, buffering the characters. The class has 3 overloaded write methods that provide for efficient writing of characters, arrays, and strings. In this program, strings of employee data are constructed within a loop that executes while the user doesn't enter the quit value. When a string is complete, that is, when it contains an ID number, name, and a pay rate separated with comma, the string is sent to the writer. The write method accepts the string from position 0 for its entire length. After the string is written, the system's new line character is also written. Although a data file wouldn't require a new line characters of each record, placing each record on a new line makes the output file easier for a person to read and interpret. Because not all platforms use a \n to separate new lines. The bufferedWriter class contains a new line method that uses the current platform's line separator. Alternatively, you could write the value of system.getProperty, then you have a line.separator. So this method could return the default line separator for the system. When the user enters quit value, then the loop stops. Then writers.close. So it will close the string, flushing it first. If the errors occur, the control flow of the program will go to the catch block for the exception message. This program reads employee.txt file we created in previous slide. The program declares an input string for the file, then creates a buffered reader using the input string. The first line is read into a string as long as the readLine method doesn't return null. The string is displayed and the new line is read. In the previous program, we read each line from the file. It will be useful to split the line into the useful fields. The string class split method accepts one argument that identifies the field delimiter. So in our program, it's a comma, and it returns an array of strings. Each array element holds one field. Then methods such as a parseInteger and a parseDouble can be used to reformat the split strings into their corresponding data type. So in this program, a line is read, then the line is splitted, and we pass the delimiter as an argument. The delimiter is a comma. We define as a comma. So the ID, the first ID field equal integer that pass integer and the array 0. Then we assign the array index 1 to the name field, and we use double that pass double array index 2, that's the third element in the array, and we assign to the pay rate. In previous examples, we see sequential access files, which mean that you work with the records in sequential order from beginning to end. Business store data in sequential order when they use the records for batch processing, which involves performing the same task with many records, one after the other. For many applications, sequential access is inefficient. These applications, known as real-time application, require that record be accessed immediately while a client is waiting. Those are usually interactive programs. Sequential access in this scenario is not efficient. Instead, we should use random access files, files in which records can be retrieved directly in any order. Random files are also called direct access files or instance access files. We can use Java's file channel class to create random access files. A file channel object is an avenue for reading and writing a file. A file channel is seekable, meaning you can search for a specific file location and the operations can start at any specified position. This table describes some file channel methods. We can open a file. We can use a method position. So this position has no argument, so it returns the channel's file position. And we also have a position which we pass one argument, that's the set the file position. So we pass one argument, and this method will set the new file position. We have a read method to read a sequence of bytes from the channel into the buffer. We also have a size method to return the size. And we have a write method to write a sequence of bytes into the channel from the buffer. This program declares a file and writes some bytes in it randomly at position 0, 22, and 12 in that order. Here we create a byte array. For example, a byte array can be built from a string using the getBytes method as follows. We need to use byte buffer. Byte buffer is simply holding a place for bytes waiting to be read and written. An array of bytes can be wrapped or encompassed into byte buffer using the byte buffer wrap method. Wrapping the byte array into a buffer causes changes made to the buffer to change the array as well, and cause changes made to the array to change the buffer. The byte array can be wrapped into a byte buffer as follows. You can use the files class new byte channel method to get a byte channel for a pass. The new byte channel method accepts pass and the standard open option argument that specify how the file will be opened. The byte channel returned by the new byte change method then can be cast to file channel using a statement similar to the following. fc.position 0, so we'll set the channel's file position at 0. In this while loop, the has remaining method can check whether the byte buffer's content has been used up, and if not, there's still something remaining, it will write to the declared file channel with a statement fc.write out. The out.rewind is to go back and reread the data in the buffer. Rewind method reposition the byte buffer to the beginning of the buffer. fc.position22, so the file point will move to the position 22 and write the contents in the buffer, and out.rewind will go back to the beginning of the buffer and the file fc.position12, so the file pointer will be point to position 12 and rewrite the context XYZ in the buffer. So when everything is done, the fc.close, so the file will be closed. So in this program, we first put contents in the buffer. Then we write the buffer contents to a file at a specific positions. Writing characters at random text file locations, as in the previous program, is a limited value. When you store records in a file, it is often more useful to be able to access the 8th or 12th record rather than the 8th or 12th byte. In such a case, you multiply each record size by the position you want to access. For example, if you store records that are 50 bytes long, the first record is at position 0. The second record is at position 50. The third record is at position 100, and so on. In other words, you can access the nth record in a file channel named fc using the following statement. fc.position, then you pass the argument like n-1, then multiply 50. Here 50 we assume each record has a 50 bytes. One approach to writing a random access file is to place records to the file based on a key field. A key field is similar as a primary key in a database. That's a unique field that identifies each record. For example, for employee ID number, last name, pay rates, obviously the employee ID number should be the key field. In this program, a string that represents a default record is declared as the 3-digit employee number is set to 0. The name is set to 7 blanks. The pay rate is 00.00. The string ends with the system line separator value. A byte array is constructed from the string and wrapped into a buffer. Then a file is opened in create mode and a buffer writer is established. Then the loop executes 1000 times. Within the loop, the default employee string is passed to the buffer write object's write method. So in the output file, we can see those default record. The ID is 000. The comma is the separator. And now we have a blank field for names. That's 7 characters. Then comma. Then the pay rate is 00.00. So there are 1000 default employee records are written in the file. The application in this program creates a single employee record. The record is for employee 002 with the last name of Newman and a pay rate of 12.25. Also concatenate with the new line separator. The length of this string is assigned to REC size constant. After the file channel is established, the record is written to the file at a position that begins at 2 times the record size. The value 2 is because we have the formula before n-1, so it is the third record because the records start from 0, 0, 1, 2, that's the third record, so 3 minus 1 equals 2, then we multiply the bytes of the record. We use the statement fc.position, then pass the argument 2 multiply rec size. You can see as output, the random employee.txt file is updated. The employee's data record is correctly placed in the third position in the file. A program that inserts one hard-coded employee record into a data file is not very useful. This program accepts any number of records as user input and writes records to a file in the loop. Each employee's data value is accepted from the keyboard as a string and converted to an integer using parseInteger method. Then the record's desired position is computed by multiplying the ID number value by the record size. The employee's ID number will be used to determine the record's position. The position is the ID number value, multiply the size of each record. A random access file is created and it can be accessed as a sequential or randomly. For example, the random employee.txt file has 1,000 employee records, but only 4 of them contain actual data, so others are just default record data. Displaying every record in a file would result in many irrelevant lines of output. It makes more sense to display only those records which an ID number has been inserted. So this application reads through the 1,000 record files sequentially in a while loop. The if statement checks for valid non-zero ID numbers. If 000 could be a valid ID number, then you would want to check for a name that was blank, a pay rate that was 0 or both. So this example demonstrates you create a random access file, but you also can read sequentially. You can access the file sequentially. If you simply want to display records in order based on their key field, you don't need to create a random access file and waste unneeded storage. Instead, you could sort the records first. The benefit of using a random access file is the ability to retrieve a specific record from a file directly without reading through other records to locate the desired one. In this application, the user is prompted for an employee ID number, which is converted to an integer with the parseInteger method. So the position of the record is calculated by multiplying the ID number by the record size and then position the file pointer at the desired location. The employee's record is retrieved from the data file and is displayed. Then the user is prompted for the next desired ID number. In this program, we see buffer equal byBuffer.wrap data. So data is a byte array. So this one, data is wrapped with the buffer. So when we adjust the file position to the right position and we have a fc.read buffer. So we read buffer actually will read the information, the contents from the buffer into the data, which is the byte array. Then s equal new string data. So we create a string from the byte array, and we can output the print out the ID, hash ID, then concatenate with a space, and concatenate the s, which is a string. This is not covered by the book. The Java actually has a random access file class. Allows to move, navigate a file and read from it or write it to it as you like. Before you can work with random access file class, you must instantiate. So you have a random access file equal new random access file. And you give the path and have a R or W. So that's the access mode. R is for read mode. RW is for read and write mode. RWD, it's a read and write mode, synchronize. All updates to file content is written to the disk synchronously. In RWS, read and write mode, and synchronize. All updates to file content or metadata is written to the disk synchronized. To read or write at a specific location in a random access file, you must first position the file point at a position to read and write. So this is done using the seek method. So here's example file.seek 200. You can obtain the current position of a Java random access file using its getFilePointer method. The current position is the index or offset of the byte that the random access file is currently positioned at. So here example, the current position of a random access file is a long position equal file dot getFilePointer method. We can read an array of bytes from random access file. So here is the example reading an array of bytes. So we have a random access file, random access equal new random access file. It's a read mode. We instantiate byte array object. Then we read a sequence of bytes into the dashed byte array passed as a parameter to the read method. The read method will start reading the file from the current file position of the random access file. The read method will start writing data into the byte array starting from the array position provided by the offset parameter. So here we set offset equals 0, so it starts from the beginning position of the byte array. And at the most number of bytes provided by the length parameter. So the length parameter specifies how many bytes we should read. This read method returns the actual number of bytes read. Writing to a random access file can be done using one of its many write methods. So here is the example. This example writes the array of bytes to the current file position of the random access file. Any bytes currently at this position will be overridden with the new bytes. Just like with the read method, the write method advances the file pointer after being called. That way, you don't have to constantly move the file pointer to the right data to a new location in the file. The random access file has a close method, which must be called when you are done using random access file instance. So from this example, we use the close method to close the Java random access file. We can see random access file is very easy to use. In order to use, you must import java.io.random access file at the top.